Alright, welcome GeoTrig. This is section 7.3, proving triangles similar. The essential question is, how can you show triangles are similar without knowing their whole life story and listening to their drama? Okay, we'll go with that. Let's begin. So there are three easy ways to determine whether two triangles are similar. And they're right here. Angle-angle similarity, side-angle-side similarity, and side-side-side similarity. So let's go over the proofs of each of those, or the theorems, or the postulates. So angle-angle similarity says that if we have two angles of one triangle that are congruent and two angles of another triangle, then the triangles are similar. So you know S and R are equivalent to M and L, so you can say those two triangles are similar. And that kind of makes sense because if you know two angles, you know the third one. It's just whatever's remaining, and it's got to be the same one at this side. And we said in the last section that if they have similar shapes have congruent angles. So that makes sense to me. Let's look at the next one. Side-angle-side similarity. If an angle of one triangle is congruent to an angle of a second triangle, and the sides that include the two angles are proportional, then the triangle is similar. So you got an angle, A and Q, and they're congruent. And then AB is congruent, AB over QR is proportional, the same way AC over QS is. Then you have similar triangles. Cool. Let's look at the last one. Side-side-side similarity. If the corresponding sides of two triangles are all proportional, then the triangles are similar. So AB over QR, and then the teal ones match up, and then BC over RS. If those are all equal proportions, then the triangles are similar. Cool. Alright, indirect measurement. This is another vocab word here. It's where we can measure using properties of similar triangles. And I hope we can try this out in class. This is cool, but let me explain this example. So like, this guy has to measure the height of this mountain right here. But he just doesn't have something to measure that long. But he can using proportional triangles. So if you put a mirror on the ground, we've got a mirror right here down here. And if you know your height, so you position the mirror, you have to back up, and you keep going back until you get a point where you see the very tip of the mountain in that mirror. So that knows from his eyes, and this is a bad picture, he should be like right up here. From his eyes, hitting that mirror, going all the way to the top of that mountain, we have two proportional triangles right here. Because these angles are the same. And these angles, they're both right triangles, the height of the guy to the ground and the height of the mountain to the bottom. So we got proportional triangles right here, angle-angle, or similar triangles. So using those similarities, he knows the height of his eyes and he knows the distance to the mirror and the mirror to the mountain. You can actually figure out how tall a mountain is or how tall a building is. It's kind of cool. Let's try some examples. Pause the video. Are the two triangles similar? How do you know? JKL is proportional to PQR. So J is proportional to P, and K is proportional to Q, and this one is with this one. Do we know that they're similar? Well, one thing, I don't know what L, I know what L and J is. I know K must be the remainder, which is going to be 80. And then over here, this P must be the remainder. If we got 55 here, it's going to be 25. Are these triangles similar? No. We can say that because we got 80 and 85, K and Q, they should be equivalent, or they should be congruent, but they're not congruent. So we can say angle K is not congruent with angle Q. That's all we need to know. That's the same thing with angles J and P. So nope. Nope. Next one. Are these two triangles similar? How do we know? Okay, so we know these are 45. And then we know these angles are vertical angles here. So whatever that is, those two angles, angle WSR and VSB, we know those are congruent. So we have, with each triangle, we have angle R is congruent with angle V because they're both 45. And then we have angle, let's go on this triangle, WSR has got to be congruent with angle VSB because they're vertical angles. And so we have an angle and we have an angle, and guess what? That's all we need because angle-angle similarity. So the two triangles similar? Yup. How do we know? Angle-angle similarity. Next one. Pause the video. Okay, how are these triangles similar? Well, we know the lengths of each side, so I bet we have to check by side, side, side. So let's figure this out. Now the question is, how do you rearrange the order? Well, this is like the longest side. It should go in the same order, like the longest sides together, the medium side should be together, and the baby side should be together. So it should be SU over XW should be equal to the proportions of the medium ones. Let's see, UT over the medium one on the other one is VW, which should be equal to the babies, ST over VX. So looking at those proportions, SU, so 10 over 15 should equal, in the middle ones, 8 over 9, 8 over, my bad, 12, which should equal 6 over 9. And reducing all those fractions, 10 fifths is reduces to 2/3, 8 twelfths reduces to 2/3, and 6 ninths reduces to 2/3. So are the triangles similar? Yep. How do we know? Side, side, side similarity. Next one. Oh, that's it.